there's a limit to the size of a white dwarf, and this limits 1.4 solar masses. And it's based on how fast the electrons can possibly be moving while being confined. So, so something will happen if if a white dwarf can exceed this limit, right? Effectively, some of the carbon fuses, or some of the layers are pushed off. So when the star forms, it's limited by its size, right? It's limited by, you know, how much stuff can be there. So stars forming, but we've already seen one example. Sirius A and B are, stars in a binary system. One's a white dwarf. It's not uncommon, and we can ask, well, what happens in this binary system? And we've talked about it a little bit. What happens when a main sequence star and a red giant are in a binary system? There's mass transfer, right? And so, uh, we talked about stars um, gaining and losing mass, but eventually one of the stars will be a white dwarf. And we can ask what happens. And what happens is it can steal matter from the other star. This matter falls inwards, and it has angular momentum because it's orbiting the white dwarf, which means it's going to form small flat disks, just like every other thing with angular momentum seems to. And so around a white dwarf, you can have an accretion disk where matter has started orbiting and it's made up a dense layer of material. And this layer of material is going to glow because it's particles that are bumping around against each other, and friction is going to cause it to heat up, and that will cause it to radiate away. And as it radiates and loses energy, it will fall inwards. Right? The friction is going to cause the disk to be visible. It's going to cause it to radiate, and the material will fall onto the star. And so eventually the star will grow in mass. Right? This white dwarf will grow in mass. So the structure for most of these binaries is going to be a carbon core or a carbon and oxygen core, and this infalling matter is going to make a shell of hydrogen. And this shell of hydrogen is going to heat up. It's effectively being pulled down onto the star, is trading gravitational energy for thermal energy. It's heating up. Eventually, it can get hot enough for that hydrogen to fuse. And when that hydrogen fuses, it fuses all at once. There's no outer layers to control it. There's no way of stopping the fusion, in a sense of there's no feedback. So the outer layer of the star explodes, and this is called a nova. It's distinct. You notice we called supernovas super. They're much more brighter than novas. Novas are just a sudden brightening that then goes away, and it's not periodic. It depends on the rate the matter is falling in. So these novas are just sudden brightenings where fusion starts on the surface of the white dwarf. And so temporarily it'll get a lot brighter. There'll be matter blown outwards. The energy will push other bits of the accretion disk outwards, other parts of the white dwarf outwards. And so you'll see, blobs of gas get ejected outwards. And that will, show a nice pretty remnant again. So you can also have um, additional effects. The matter still build the star can still grow in size. And this is a good pausing point.